All right, so what we got is the hand twist model. So, Jonathan, make sure we're paying attention here. Hand twist model. This is actually college level work. I got this from a college class, so but it's fairly simple. We're looking at low pressure versus high pressure. Yesterday you took some notes on pressure, and basically, if you got a low pressure system, you don't have as much force pushing down on the air and the moisture. And so the moisture is allowed to rise. And what can form if moisture rises?
Rain.
Rain, you got it. You can form clouds and then cumulonimbus clouds and thunderstorms. So low pressure systems are indicative of rainy weather, gloomy skies. So what do you think the pressure is outside the pressure system? Pretty much low. It's probably on the outer band of a low pressure system. So what you guys are going to do is you're going to put your hand, whichever hand you want, and you're going to mark. You're going to, kind of like that. You're going to mark the tip of each of your fingers, and you're going to trace it, making a little circle. And we're going counterclockwise. So you're going to make the arrows go to the left, in this case to California. Alright, you're then going to move the paper, or your hand counterclockwise, or you can move your paper clockwise. Basically you want your top of your fingers pointing California, and you're moving your fingers in. And if you do that, your palm is moving upward to simulate moisture. So we do that. A lot of squeakiness there.
I was just thinking about it goes the baby.
All right. You're then going to do the same exact thing a third time. Moving it so you're facing Texas, and you move your hands in, not your hands, your fingers in even further to make a tighter circle. Trace them. And lastly, you do it a fourth time, and you scrunch your fingers in as close as you can. And there you go. And just a Sharpie might actually work better. And there we go. So we got a counterclockwise rotation. And what's happening is you got the water level rising higher and higher and higher, forming clouds and rain. You got it. So this is the same type of motion that happens in cyclones and hurricanes. And the reason hurricanes form is because they have a lot of moisture and warm water, warm temperature. But once they're on land, there's not enough moisture, so the wind speed can't pick up fast enough. Right. And hurricanes happen in a particular season because they need to have a specific level of energy, so it needs to be a certain temperature. So typically in the fall. Alright, so if you flip it over, we got the same thing, but it's for high temperature. It's for the, not high temperature, no. We're talking about pressure, high pressure. So in this one, your water moisture is in the air, but the pressure is so high it pushes the moisture down. And so it goes to the ground. Which would mean that in the sky, are there any clouds? No. So high pressure systems are sunny days. Good, right, sunny days. Alright. So in this case, we're going to start our hand twist model with our fingers crunched, and our arrows are going to go clockwise. All right. So we go clockwise. So this time we're going to hit the eastern seaboard first. And we're going to spread our fingers out a little bit. And you can see that the palm of your hand is moving downward. Because that's representing the moisture. Alright, then you're going to move it towards Texas. You almost spread your whole hand out, but not quite. Your palm is moving downward, so moisture is moving downward. Alright, and then you're going to move facing California and you put your whole palm flat. Alright, so because the rotation is moving outward, it's causing the moisture to kind of dissipate and flatten out and creating no clouds and sunny air. Alright. Like if you remember with the groundwater activity, each line represented a certain amount of concentration of arsenic. If this were temperatures, like tomorrow I'm going to have an example of temperatures, each line would represent like 50 degrees and then 60 degrees. In this case, it's pressure, so it's representing millibars or isobars of pressure. So we got 1008 isobars right here. And we want to go by, let's just say, 4. So after 10,008 would be 10,012. I only see a couple of 10,012s. There's one here. There's one there. There's none here, but between 1015 and 10,008 is a 1012. So I'm going to make my own dot. Between a 1013 and a 1008 is a 1012. Between a 1018 and a 1011 is a 1012. And I'm going to connect my dots. And you want to make it curvy, not boxy. Between 10,008 curvy. Between 10,008 and 1014 is a 1012. Between 08 and a 17 is a 12. 1008 and a 1016 is a 12. And so on. Alright, so there is my isobar. So we got 10,008, 10,016. After that would be 10,020. So I look for all the 1020s. Between 1019 and 1021 is 1020. 1020. And these are just estimates. Yeah, you wanted, ideally you should do this in pencil. Unless you're an experienced pro, then maybe.
I'm going to do it in colored pencil, so.
Close enough. Looks like 1024 would be the last one we could do. And that's that. And the center of this system, it looks like this center of the circle. So is this a low pressure area or a high pressure area?
No.
It's a low pressure, so you can write a big L for low pressure. So is this going to be sunny or rainy?
Rainy.
It's going to be a rainy day. Wisconsin might be a combo, depending upon how how the clouds are spiraling. All right, that is that.